Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2017, time zone 2, question number 6. A concept related to topic 3, periodicity, but a simple one. Let's see which property increases. So what we are going to find is the increasing property trend down a group. Normally two directions we consider either be across the period or down a group. So this time down group 1 of the alkaline metals. Obviously the common description of all the elements within group 1, we call them alkaline metals, right? So the first one, which is atomic radius. For this time, students can easily realize that A is the best choice or is the correct choice because the atomic radius is obviously increasing because of more shells, right? More shells or more main energy level when you move down the group, right? So imagine the first one, which is going to be 2,1, so like lithium. So the next one will be like 2,8,1 and then 2,8,8,1 and so on and so forth, right? So obviously the number of occupied electron shells will be increasing when you move down the group. So this is obviously what we are understanding across the period and also the meaning of period and group. So that's why although they're all having the outermost shell electron to be 1, they are now having an increasing size as they occupy more electron shells. So that's why the distance between the nucleus and the outermost shell electron, the so-called atomic radius, is going to be increased. So that's why simply understanding is A. But again, we should further look for why B, C, D are not the correct answers. For B, electronegativity. So that simply means the attractive force or the tendency to attract a bond pair electrons from an element because of the nucleus, right? So reminds you that B, C, D are all can be explained by a concept called effective nuclear charge. Nuclear charge. In short, we call it E and C. Actually, what is effective nuclear charge? It is a concept related to the net attractive force from the nucleus to the outside world electrons. Student can simply understand it as a pulling force that after the reduction of the shielding effect by the inner shell electrons, so the nucleus should exert some attractive force to the outside world electrons, right? But in terms of the attractive force, there's a reduction because of the inner shell electrons that exert some what we call shielding effect. So the net consideration after combining the nuclear charge plus the shielding effect is the net consideration of the strength of how strong the nucleus can attract the outside world electron. So that is what we call the effective nuclear charge. And mind you, effective nuclear charge decreases down a group. Students should be able to know the reason behind after learning the lessons. So that's why I remind you that effective nuclear charge decreased no matter which group it is. So obviously including group 1. So that means the net attractive force from the nucleus to the outside world electron is actually decreasing, right? So that's what the tendency for you to attract the bond pair electron within a covalent bond is still decreasing. So that's why this should be decreasing. And also, first IE is actually talking about the attraction from your nucleus in attracting the outermost shell electrons, right? Stronger the attractive force, larger the first IE. So in this case, as the effective nuclear charge is decreasing down the group, we should expect it will be getting easier for us to remove the outermost shell electron when you move down the group. So that's why the first IE is decreasing. Same as the melting point, because in this case, for group 1, all about metals. Melting point this time is related to the strength of metallic bond. Right? And what is about metallic bond? It's the electrostatic attraction between the positive charged metal ion and the outermost shell delocalized electrons, right? So that's why this time something that really similar as the factor about effective nuclear charge, right? So when the nucleus can no longer attract that electrons that strong, so eventually the strength of metallic bond will be getting weaker as well. So that also explains why melting point is decreasing down to group 1, same as other physical properties like the rigidity or so-called the rigidity, the strength of the metals is decreasing. So that's why only the size is going to be bigger and bigger. So that's why answer obviously A.